We have already gone through the analogous between nucleus and the liquid drop. Apart from the similarities in the properties, liquid drop model also gave a formula for calculating binding energy of the nucleus. The binding energy of the nucleus comes from the contribution from proton and neutron, and there are certain factors affecting the binding energy value based upon the number of neutrons, shape of the nucleus and the interaction between the neutrons and the protons. So, here this is the formula which gives us factors contributing for binding energy in a nucleus, where EB stands for binding energy of the nucleus, AVA stands for volume energy, ASC stands for AS into a to the power of 2 by 3 stands for surface energy, AC into Z square by a to the power of 1 by 3 is Coulomb energy, AA into n minus Z square by divided by A is asymmetric energy, delta of A comma Z is pairing energy. So, as we have figures down, volume energy, surface energy, Coulomb energy, asymmetric energy and pairing energy, of which volume energy always increases the binding energy, whereas surface energy contributes for decrease in binding energy. Coulomb energy is also a negative energy. Asymmetric energy is also a negative energy, whereas pairing energy depends on the number of neutrons and protons. Before going in detail, so this is a brief idea regarding the contribution of binding energy proposed by liquid drop model, and this formula is also called as semi-empirical mass formula. Now, in detail, volume energy. The volume of the nucleus is proportional to A. So, volume energy is proportional to binding energy is, which says that binding energy is proportional to the volume. Strong nuclear forces between neutrons and protons are responsible for this volume energy. The total binding energy of nucleus is proportional to total number of nucleons, capital A in it, where A1 represents undetermined constant contributing to the binding energy. Surface energy. The nucleons at the surface of the nucleus are less tightly bound, like the molecules on the surface of liquid, which will have less surface forces acting on them. This reduces total binding energy of the nucleus. As a molecule at the surface of a liquid is attracted less strongly in one direction compared to a molecule which is inside the liquid drop, similarly a nucleus which is on the surface will have less attraction towards the other nucleus compared to the protons and neutrons which are at the center of the nucleus. Therefore, the number of nucleons on the surface are proportional to the surface area of the nucleus. The number of nucleons on the surface, if the surface of the nucleus is considered to be sphere, is proportional to a to the power of 2 by 3 from the formula of surface area given by 4 pi r square, where r is in turn given by r naught into a to the power of 1 by 3. By substituting a in place of, by substituting r value in terms of a in 4 pi r square, the final relation will have E surface energy is equal to 4 pi r naught square into a to the power of 2 by 3, where 4 pi r naught are constants which is replaced by As. As represents the proportionality constant of surface energy, and the final equation of surface energy comes to Es is equal to minus As into a to the power of 2 by 3. The minus sign here represents, as the number of molecules on the surface increases, the attractive force among the nucleus decreases kabatti we have a negative sign here. Similarly, surface energy is just analogous to the surface tension of a liquid, which is true in case of liquid. Liquid lo surface tension kuda it will also have the same impact, and hence surface energy is also an analogous, can be taken as an analogous to the surface tension. The third energy is Coulomb energy. Coulomb's repulsive forces are produced due to the mutual repulsion of protons, which are positively charged particles of the nucleus. We have no problem with neutrons because they are 0, their charge is 0. The problem comes with the protons. Since all protons are having positive charge, positive always repulses kabatti, the interaction between protons will always lead to decrease in binding energy. Now for suppose if the nuclear charge, if the nucleus is having Z number of protons in it and the charge is given by Ze, then the electrostatic potential energy is given by V is equal to 3 by 5 Z square E square by R. The Coulomb repulsion is always proportional to electrostatic potential, thus Coulombic energy is given by, or Coulombic energy is proportional to 3 by 5 Z square E square by R, where R is again replaced with R naught into a to the power of 1 by 3, thus giving us the final equation as